Today we're going to take a quick look at saving operation plans in the technology database, especially as it applies to things like laser cutting. So we have a simple part out on the screen, and the first thing that we want to do is we want to change a couple settings so that way as feature recognition runs it sees these holes as pockets versus drilled holes, because obviously if we're using a generic laser we want to cut that inside shape. So if we go to our CAMWorks options, we have the ability in the mill features to set the hole recognition diameter. So if we set that to a max diameter of say 1 thousandths, any diameter that's bigger than 1 thousandths in diameter it's now going to see as a pocket. So that is the first area that we change and set. You do have the ability to do condensed split holes if you're working on imported parts as well. But for this example we're just going to go ahead and just leave that max diameter there. And then as we come and look at our stock, we'll just leave it as our standard shape at the moment because what we're concerned about are the inside profiles. Now, if we were to go and just say I want to run and do extract machinable features, you'll notice it comes up with some roughs, it comes up with some finishes here, and then in our roughing you'll notice that it's going to create a tool path here. Well, that's because the diameter of our tool for one is set to 1/2 inch. Generally on a laser you're looking at 5 thousandths to 7.5 thousandths in diameter. The other thing is we only want to cut it once, and we want to use cutter comp. That way it offsets the beam thickness to the side. And so for those we actually use the contour mill. So the first thing I'm going to do is I'm going to come through and I'm going to delete the rough mills. All I'm concerned with is I want these finished contours. Now from here we're going to go ahead and we're going to create a tool that is the diameter of our laser beam. So we're going to come over here and we're going to create a new tool, and it's going to be, we'll just do a flat end mill. So the cut diameter is 0.005. The shank diameter you could set to 0.005 if you wanted to. Flute length, shoulder length, cut length, some of this stuff doesn't necessarily matter when you're talking laser beams because of auto height that's turned on the machine where it measures your height and distance. So on these generally I've just left them to a standard setup. And then from here for the comments, we'll just do something similar to that. So we'll hit OK. And so now we should have our 5 thousandths flat end. So we're going to take these two, we're going to drag them down here and drop them in there, and then we're going to take and drag that one down there. Now if we look at our tool crib in general, you can see we have different ones here. We can create a new one, but let's say from now on we always want that 5 thousandths end mill to be added in here for the laser beam. So if we do a save tool crib, we'll call it laser. We now have one that we can use that allows us to always have that in there. And what that'll do is that'll keep it by default. So if you do tool crib priority, these tools will now show up. So as you can see now, they're all set to 5 thousandths end mill. We'll generate our tool paths, and now you can see that the tool paths generate successfully. The only issue we have now is we have several depth passes. Well, because it's a laser beam, we just want to do one pass. So we'll come in here to the specific tool, and for our depth, we're going to change the first cut amount to say, let's say we're going to do 1 inch. We have a 4,000 watt laser, we can do 1 inch plate. So we always want the first and maximum to be 1,000. So we'll hit OK. And now we should have one pass at full depth, but you can see we still have the step over here. So for our step over, this is where we can change our side parameter and our step over that goes from there. So you can see here we can change our percentages as well. So if you wanted to have a final feed rate, for rough passes, the previous allowance, set our cut amount to 1 inch. And now we have one pass that comes in. Now from here you could set your custom lead in and lead out if you wanted a bigger lead in or lead out on this. Obviously, most people have standards on how they want the lead out to be. So let's say our lead in amount, we'll change these to numbers versus percentage. We don't want any overlap on this one. We want the arc radius to be 0.60 thousandths. Let's say our lead in is point. That way we're a little bit away from the edge of the part so we don't leave a dimple. And so now we have that process set for that part. So we can go back through, we can do the same settings on these to where we'll change these. No overlap. And we'll go to our contour. Again, we'll do 1 inch, 1 inch, settings. You can see we have a little bit of a lead in. We got to make an adjustment to here. And again, these all come from different types of settings you can do. So let's say we do arc angle. Oh, selected the wrong number there. So we'll do arc angle at 45. So arc radius, lead amount. For a circle, we'll shrink that down a little bit so our lead in amount. It looks like our start's the center of the hole. So from there, we'll just go ahead and we'll just do a perpendicular on this one. There we go. And then we'll make the same setting changes on this one. Now, you wouldn't have to necessarily do this on all of these. You could do it once, run feature recognition, and have it find it again. But just to give you an example on changes that we're making here, just so you can see the process. Now, if you had internal, external, you could do all that. Your cut method, climb or conventional. Some people like to cut counterclockwise on internal, clockwise on external, so you can set all of that up as well. And then from your feeds and speeds, you can use feeds and speeds here if you wanted to, depending on your post processor. Now, that said, it may be a scenario where your tech table in the machine is calling all that up. So at that point, then your feeds and speeds don't really matter unless you're doing etching, or let's say in aluminum, you want to do a slow lead in and then take off to 100% feed rate. You could set all of that information in here and then have that stored based upon the material type you're using. And that speeds up some of your programming too if you want to go to that automated level. So once we have all these set, you can now see if we do simulation. We have our 5 thousandths mil, and it's going to come around and create that shape. It's going to come around and create that shape, and it'll create that shape. So we now have our tool paths on how it's going to cut. We know that that's verified with a single pass. So the next question that comes up is, okay, I created all these settings, but let's say going forward, all I ever want to see is a contour, and I want to save these settings for the single pass, the depth, the diameter. How do I do that? Well, the way that you do it is you actually come over here and you right click and you do save operation plan for each feature. So you have an obround and a circular. So you would save the operation plan for obround, then you would save the operation plan for the circular pocket. And that's all you have to do, because it looks at the geometry and the size and then it updates accordingly. So generally what I do when I try to teach the database how I want to program, especially when we're talking like lasers, what I do is I go through and I program the parts, then I come over here and I save the operation plan, and then I tell it I want to overwrite the existing. And when I do that, it'll take whatever it originally found and overwrite the existing. Now, you do have the ability to create a new one. So I could create a new one called laser slot, and I could set it as default, and what that'll do is now it will always find that as the default. So if I set it here, this will now be the default standard that I have. So when I hit OK, then it's going to ask me what geometry size do I want to go to. By default, it's going to say it's going to have a box width of this feature. The depth is going to be here, from here to here. Well, let's say on my standards, I know that for that size, from 0 to 1/4 inch steel, I want it to fall within that realm. And then from box width 0 to, let's say we do 1 inch. So now when it looks at this geometry and it finds anything from 0 to 1 and a depth from 0 to 1/4, it's going to apply all those settings, including my lead in and lead out. I can also come back here and I can go ahead and save the operation for this. And I can create a new one. And we'll do laser circle. I'll set that as my default. We'll hit OK. And I could set the same settings here. So I can say up to 1/4 inch deep. And for this circle, I can go from 0 to, let's say, 6 inches. And now I have those set. So what does that mean? If I come back here and let's say we delete all our features, so we don't have anything left here, and I come back and I do extract machinable features, it now found it with a 5,000 end mill. It found it as a laser slot, laser circle, and everything is taken care of. Now you'll notice I have a face feature on here that keeps showing up. All I have to do is come into my CAMWorks options, go to mill, and turn off face, and it'll stop finding the face features. So generally for laser, I would just do bosses, holes, and non-holes because all I'm worried about is a perimeter. So we'll run it again, and now I have my standard set. Delete that. Since it was in there before, it's going to be that way. So if I come over here, and let's say we put in another hole, and we put in another slot, we'll set that. If I come back into CAMWorks and I do extract machinable features, you can now see that I have laser circles, laser slots all found. They all use a 5,000 end mill, and even though they're different diameters, I'm still keeping those same parameters. So that's a real quick overview of how you can set CAMWorks up for automatically defining laser features. It's real simple. You basically just teach it, save the operation plan, and away you go.